and we are solving we finished 47 problems today, and we started solving problem 48. I have to I had to restart the streaming, but anyway, so we are in problem 48. I haven't read the problem yet. Let me just copy the problem first, and it looks like a relatively simple problem to solve, because I think we have looked at Python's infinite precision arithmetic, and this is, I believe, going to solve the problem. I have to make this to the power, and then this to the power, this to the power, this to the power, and the same thing over here. And this to the power, like that. Oh, what happened? Plus something's not right. Okay, never mind. There is some problem over here which I cannot seem to figure out what happens to be the problem. To the power 2 plus 3 to the power 3. Yeah, I don't know. There's some problem. But anyway, so let's see. The series 1 to the power 1, 2 to the power 2, 3 to the power 3, all the way to 10 to the power 10 is that. So in Python, 4 to the power 4, I think this is not correct. 4 to the power 4 looks like that, and we just need to loop and we just need to make sure that 1000 to the power 1000 is what it is, and this is okay. Python can handle this perfectly well. So we just need to, for I in range 1, n in this case is 10, so for all the way from 1 to 10, n plus 1. Okay, we are just going to say I, and we make sure that we have the right range. This is I times I, it's I to the power I, and we just need to sum it. So we are using an iterative solution over here. So this becomes an iterator, and we can just sum it like that, and the answer is this. So we just need to increase this to 1000, and we should get this number, whatever it is, and we need to get the result. is that, and result is the str of result, and we want to find that's everything, but we want to find the last 10 digits. So let's look at last 3 digits, and the last 3 digits should be 700. We just want to make sure that this is correct. That's correct. The last 10 digits should be that, and that's the result. That's the result. Okay, so let's solve another problem. This is just too easy. It's just Python. I don't have to work hard for this. Okay, let's solve the next problem. So let's save this, and let's look at the next problem. Okay, and primes. Primes. This is like every third problem is a prime problem. So that's the problem, and this is problem 49. This is problem 49, and these are prime permutations. That's the problem. Okay, what did I just solve? Did I solve 48? What the hell is this? 49. What is this? 48. Can I save it? So I have problem 49, and this is what I'm looking at. Yeah, okay. So I actually solved problem 48. All right. Okay, so let's look at the problem. The arithmetic sequence, the arithmetic sequence is generally this is this plus a number. Okay. This seems like we need something. Let me take out the, what is it? Oh, I have to connect to the screen mirroring software. All right. Okay, so let us look at this problem. So an arithmetic progression or arithmetic sequence is basically characterized by n1, n2, n3, such and so on, such that n2 minus n1 equals p, then n3 minus n2 equals p, and so on. So you can write this sequence as I times p plus n1 for all I, or the other way of saying that is I is a set of natural numbers. So I is a set of natural numbers, like that. Okay, so we need to find a set of primes. So and we know that this and so on is a set of primes. There's one other 4-digit increasing sequence. Each of the 3 terms are prime, and each of the 4-digit numbers are permutations of one another. There is one other 4-digit increasing sequence. what 12-digit number do you form by concatenating the 3 terms in the series? So we know that I was a bit afraid that this would the number of digits in the number of digits in the primes is not going to be available, but apparently that's not the problem. So we are just going to brute force this. We'll brute force this simply because this is a set of primes and it's not a very complicated set of primes. It's the number of primes in this sequence is very low, so we are going to just brute force this like we have done in so many problems before. So let's see. Primes is that we want let's import numpy as np, and numbers is np dot range 1 to, so now we have it's a 4-digit prime, so that's 5 digits, so everything all the way up to here will be 4 digits, and we will look at primes. Okay, so oh no, we need to go from 2 all the way up to, because 1 is not prime. I was watching a lecture by Terence Teo, and that is where he mentioned that 1 is not a prime because of some reasons. Anyway, so nums is that, and while len of nums is greater than 0, we are going to say primes dot append nums. Let's say n0 is nums, that's the first element, and we are going to append n0, and for the rest of the primes, and we are going to mask out all the things that are not that are actual factors of n0. So primes percentage n0 n0 0. So these are all the things that are factors of n0. I want everything else, and if we keep doing this, oh sorry, nums, there should be nums, I am thinking about something else. Then we should be able to get a set of primes that go all the way up to, okay, -10 onwards. -10 onwards is that. So we need to get rid of all the primes that are not 4 digits. So if p is greater than 999, that's 4 digit, and length of primes, let's look at how many we got rid of. Length of, now I won't know. Okay, so anyway, we got 1061 primes, and so now we just brute force this, where we start with a, let me see, we have all these primes, and we want to see whether, let's create a function. Check numbers. Okay, and we are going to give an index I, and we are going to give we will call it find primes. Okay, so find prime sequences. So we want to find sequences from I such that, okay, so let me try and understand what let me try and explain what I have in mind. Okay, so what I have in mind is that the first thing I'm going to do is I'm given, so these are our primes, P1, P2, Pn, and my goal is to find a set of 3 primes, PA, PB, PC, such that they form an arithmetic sequence. And since we know that there are only 3, right, the easiest thing to do is to look at, given an index I, and that's the index I over here. That's the index I over here. I want to find, given this, I want to find all primes such that there are a group of 3 like that. So basically I will, from this index, I will go through all primes, and let's say I am at this point, then I want to see, and this one is in this case PB, then I want to see whether PA plus PB minus PA into 2 is in a prime, in the prime list, and if it is, then we have PA, PB and PC as three different items that are worth checking whether oh, that's it. That once we do that, we will be able to find the 3 items. So let's see. Okay, so given I, okay, prime psi, oh, this is an empty array at the moment, and we will return the sequence. And what we want to do is P1 PA equals primes I, and then we are going to start going all the way from I plus 1 all the way till the end. And that is going to be 1061 n primes. So I will go iteratively for I in range I plus 1. So I need to take the next prime all the way up to n primes, n primes minus 1. N primes actually. Okay, and then PB is going to be equal to primes I. Oh, I should call this J. Okay, J. All right, and if PC equals PB plus PB minus PA. Right, which basically equals 2PB minus PA. 2PB 2 times PB minus PA, like that. Okay, if PC in primes sequence is that sequence is PA, PB and PC, and will return sequence, and if there is nothing, it's going to return an empty sequence. So we have that find prime sequence, and if we just naively say find prime sequence is 0, right? What the hell? Okay. I don't think this is correct. there seems to be a problem. Okay, what about 1? Wait. The numbers aren't changing. What 2? Or are they changing? Okay. There is okay. Okay. So there's some problem over here. Ah, okay, let's see. 9949 minus 5479 is that, and 5479 minus 1009. Wow. And this is in primes. Am I doing this correctly? Okay. Okay. One 487. I have no idea. Maybe I'm not reading the problem properly. So maybe we'll just stop over here for today, and then we'll continue next time. Okay, thanks.